In this video, we're going to discuss centripetal force. And we'll just define it first. It's the force required to change the direction of a moving object. Let's look at what that means. If I have an object moving to the right like this, and I have a force moving to the right, well, I'm just going to increase the speed of the object. So this is just going to increase, we'll say, the velocity. It does nothing. Correspondingly, you might say if I have motion going this way and a force acting this way, this is just going to decrease the velocity. However, if I have motion going this way and a force acting like this, now that's going to do a combination of things. First of all, only part of that, as you can see, is going to increase. You can see that it's moving up, the force is up and to the right. This is my motion. The red line is my force. Let's make that in red as well. And it's moving, the force is up and to the right. So it's going to contribute, some part of that is going to contribute to the forward motion, to increasing the forward motion. So let's look at that now. This is going to, if I break this into components perpendicular and parallel to the motion, you can see this corresponds to an increase of force acting in the direction of motion. So in this case, it's going to increase the velocity somewhat, but it's also, you can see that part of that force is pushing upward in this direction. And this is perpendicular to the direction of the motion. That's going to also change the direction. It's going to push the object upward. So centripetal force must act perpendicular to the motion in order to actually make it turn. Centripetal force acts perpendicular to the direction of motion. And I hope you know that there's that little perpendicular sign there. First of all, centripetal is centrum, which is Latin for center, and I think it's petare is Latin for to seek. So we're talking about a center-seeking force. It's pushing it towards the center, and we'll see exactly what we mean by that. If I have an object traveling in a circle like this, something has got to make it turn. And so this thing is moving in a circle here. Ordinarily, if you're moving in a straight line, if some object's moving in a straight line, what we're saying is we have to apply a force perpendicular to that motion. And if I apply a force like that, it's going to change the direction of motion. It's going to make it move like that. Then I apply another force perpendicular to that, and that's going to make it move, change direction. Then I'm going to apply another force like that, perpendicular to that force, and that is going to make it change direction. Correspondingly, as I go all around like this, as I keep applying perpendicular forces, I end up creating a circle if I kept going around. Now you can see the forces are pointing in terms of that circle. Let me just make a couple more here. We go like this, and then I'll apply another perpendicular force like that. And you can see that they're pointed inward towards the center of the force. This is the force here in red. And so it's all pointing towards the center, and then that's what has to apply. That is what we mean by center seeking. And so that's what makes an object turn. It's going to require a little modification in our definition of the first law. And in that definition of the first law, we're going to modify it as follows. So the first law, it used to be very casually, an object at rest tends to stay at rest, and an object in motion tends to stay in motion. It's the type of motion now we have to be a little more specific about. So let's modify it and make our first modification to it in this way. An object, let's do that, an object at rest stays at rest. So we're a little more definitive about that. And an object in motion stays, and here's where we add a little bit, in straight line motion unless acted upon by a net force. You can't just say force because they might have a counterforce. We need some kind of net force pointed inward in order for that to be valid. Now, okay, so we talked about a force. What are our equations? Well, as I may have mentioned, that we're going to derive the centripetal force equation in another video, but for now, I'll state that centripetal force, a centripetal acceleration, is given by this equation. So centripetal acceleration is a sub c, and I put a subscript of c on mine, that is equal to v squared, the velocity squared, divided by the radius. So that, and of course that, as any acceleration, comes out in meters per second squared. And I'll do an example of this in another video. The centripetal force, how do you think that would be defined? How would we create a centripetal force based on that definition of acceleration? Well, if you said just multiply it by mass, then you're correct. Centripetal force is going to be, and I'll use a subscript of c for that too, is going to be m times v squared over r. Or you could also write it just as f sub c equals m a sub c, if you will. And of course, as a force, it is also measured in newtons. And I'll do some examples in the next video.